Alright, so today I just wanted to talk about describing domain, range, and just the graph. Though we're not going to be determining the graph right now. That's going to come up once I start teaching calculus and the whole second derivative test, first derivative test. But first, let's just get these notations down. So this stuff will pop up when it's talking about the domain. When you see this is how you describe it. It's an open bracket. This means it will never touch that value. And then right here, this means greater than or equal to. And that will have a closed bracket. So this will pop up when you're talking about domain. Because it'll have stuff like x greater than or equal to 3, which will have... I just forgot what I was saying. 3 to infinity. And here's another thing. When you're explaining infinity... sorry. No, stuffed up. It's always going to be an open bracket. I'm not sure if I mentioned that in the other video, but just to let you know, that's what it is. And this means that you will never touch infinity, which it does make sense. Because if there was a way you could touch the end of infinity, it is an infinity. Simple as that. So if you're not given an interval, then just assume that's going to infinity. Alright. Now I want to talk about unions and intersections real quick, because we should probably differ these before we actually dive into domain. So this means union. This means intersection. There was some way people were memorizing it, like this was supposed to be or, and this one was and, but I just see union and intersection. It could work for you. I'll write it on the board, but it just doesn't work out for me. My handwriting somehow just gets worse. And this is the reasoning for that. And when you're talking about union, let's just say you're given two intervals, such as x is lesser than or equal to 2, which is lesser than -1. Alright, and let me think of another one. And then x is greater than 0. Alright, and then when you're describing this, let's say you're taking the union of that. When you take the union of that, that just means combining the two. Sorry, breathing's a little complicated. So let's see, it's an open bracket, so it will come out to a notation such as this. And the interval ends on 3 because that's the maximum value. This is the minimum value, since union just means or. So it's combining the two. So you can take domain in reference to both given intervals. So it will come out to this open bracket. But if you take the intersection, this will only take whatever's within both intervals. That's where the and part comes in. So you will have, let's see, the common values in both lines are 0 and 2. So the interval is just open bracket 0, 2, close bracket. There. It shouldn't be too hard. This is related to set theory, and I might want to talk about that once I get to discrete mathematics and proofs and crap, if I ever get to that, depending on if you guys actually want to see that. So, now let's move on. I'm expecting this video to cut out any second now, so be prepared to see a jump cut. Okay, so now let's start talking about this graph that I'm about to draw. Okay. Now, let's start describing the graph. Actually, let's just... Alright. So, let's just examine the graph. What do we see? We have a vertical asymptote, as I stated in the previous video on how to look at those. So, vertical, write down x equals 0. We'll just assume that's the origin. That could have just been a random line. But what about these parts? See, that's called a horizontal asymptote, which horizontal should have come from the name. But let's go back to the idea of limits. In order to find, trying to think of a graph. Here, let's assume that this is just the limit as x approaches infinity. Yeah. Infinity of 1 over x, since that's the graph shown here. You know, because negative goes all the way to negative infinity. You can treat this both ways. Hold up, I forgot to tell you guys about this in my previous video. So, when you're doing limits, it has to match both ways, approaching the same value. And obviously, you can't have it infinite. But it's called a right-hand, left-hand rule, I believe. And it's just, it has to approach it the same way on both sides. Like, even if there's a hole, it has to approach it like that. So, right-hand, left. Alright, now let's get back to taking the limit as this approaches infinity. First of all, you can't plug in infinity into x, because that doesn't make any sense. But what you can do is examine what the behavior of that is when approaching infinity. Here, let's think about it this way. If I plugged in 1, it comes out to 1. If I plugged in 10, it becomes a tenth. If I plug in 1,000,000, it becomes a millionth. When does that approach 0? Well, if it's at infinity, we can assume that it's already at 0. This is the thinking that you have to take. So when you're trying to solve this, this becomes 0. Take that in mind. That will become very important in the next part. So, first of all, when you take the limit as x approaches infinity for polynomials, of course it's going to come to infinity because you have it diverge. But let's say you have x squared plus 2 over x cubed plus 3. Alright, now let's take the limit of that as it approaches infinity. I forgot to write down limit, but I don't think I have enough room. But here's a little trick, because I'm not going to delve into the calculus, L'Hopital's rule. So I'm just going to show you how you can do this without actually doing derivatives. Divide everything, oh, whoopsie, by x cubed. Once you do that, you also do it to this part. I don't have any room. It becomes x squared over x cubed, which becomes 1 over x, which, again, we found the limit to be 0. But what about 2 over x cubed? It's actually the same reasoning. Let's say you have it 1,000,000 over x as x approaches infinity. It would still be the same thing, because you can plug in 1,000,000,000,000 and that'd still make it a smaller number. The big little concept. And this one turns into 1, this one turns into 0, 0, 0. So the limit equals 0 as it approaches infinity. And you can do this with negative infinity, okay? It's the same process, except it might come out to a different number. trying to think of what I was about to say. Alright, let's start talking about domain and codomain now. Because now we have tools to actually figuring out what the horizontal asymptotes and the vertical asymptotes are. I'm not going to talk about slant asymptotes. Not until later on, but domain, codomain. To B and to even more B. That probably didn't make any sense, but it will in a second. See, codomain is just another way of saying range. So it's the number becomes another number. Input, output. To B or to even more B. Wow, kind of sounds stupid, but I kind of enjoy it. Because you can have values of 2 in the domain, and it could come out to half, depending on the function given. But how do we describe domain? So, from what we see over here, we know that it goes off to negative infinity. Now, is it going to break off at any point over here? It could be 1 over x minus 999, and you would know that that's where it breaks off. So right here it breaks off at 0. So it would have a domain of negative infinity, 0, with a union of 0, infinity. And if you used an intersection, it would be nothing. It would only have a common thing of 0. And that would just not even have an image. Because, alright, before I go on, this is the image of the domain. You might see codomain in the pure mathematics classes, depending on what you're doing in the future. But for now, just know that that's what I'm in reference to. So codomain is range. But now let's start describing the range. What values can this take from here to here? It actually shares the same range. That's the cool part, because why am I stuttering? It can go all the way down to infinity based on the big little concept. So that means it reaches every single value y can actually have, the codomain can actually have. This does the same thing all the way to infinity. So now, how do we describe this? Same thing. And I mentioned intersections because I want you to get the notation, but most of the time you aren't ever going to use intersections when describing domain and range. So this is the same for the range. And the notation comes out to x, and then you put in whatever's over here. Which you would, let's say you put it down, how do I place this? Just domain, and then range. You use these colons for describing it, and it's just put range over here. By the way, if you need me to do examples, I'll do it. It's just that it's going to take me like 20 minutes longer, and every time I try and record this, it cuts out, which it might cut out now. Wait, I still have 6 seconds. I'm just going to wait for it to run out. Thank you for watching. God bless you. See you in the next video.